Happy day, students. So let us start standing waves now. Standing waves means is the energy is standing at rest. It's not being moved from one point to the other point. Okay, so how to get the standing waves? What is the procedure? It says that if there are two waves which have same frequency and amplitude, and the two are moving in opposite direction, like one is moving towards x-axis and other one is going towards negative x-axis, and they are going to interfere, then the result we obtained is standing waves. So first we will see it and then we will try to do it mathematically. Okay, so first let's say here is the first wave. It's like this. Okay, now it's reflected wave, or you can say other wave which is moving in opposite direction. This is going in the positive x-axis direction. It's a progressive wave, obviously. Okay, and this one energy is moving. Now this is going to interfere with another wave. I'm making it so that you can understand how it is. Okay, a wave like this, exactly similar wave, but this one is moving in this direction. So when they are going to interfere, what will happen? The amplitude we have assumed as same. So this point and this point, when they are going to interfere, this is 0, this is also 0. Addition is 0 only. But here, this is A, this is also A. So it will be 2A. Again here 0. Here again 2A, 0, 2A, 0. So how will be the wave? This is the resultant wave. You have to see this. Okay. We can bring it over here so that we can draw it properly. Okay. So this is like this. So I made it wrong. This is okay. This is fine. That's also okay. This is okay. Yeah. Like this. Okay. This is at this particular instant in which progressive waves are in like this. But we know that because this is a progressive wave, and if this is a source, this will not remain here forever. Now this is here right now, then it will go up, then it will come down again, then it will go further down, and then it will come. Because we are talking about simple harmonic motion. So this end is going to oscillate like this. So is for this. So in the second one, how will be the shape of standing wave? Here this is what we are calling as standing wave. Okay. And this and this are progressive waves. Now we are going to make it at another instant how these two progressive waves are. Just see them. How is the shape? Okay, so our first progressive wave, let's say now it's like this. Our source has gone up. Okay, and the other one which is coming from the other end, it's like this. Okay, to make it properly, to make it draw properly, these lines are required. Okay, so it's like this now. Okay, it's in this way. Now again, amplitudes are same. Obviously, this is also A, and this is also A. Now check here. This is positive A here, and this is negative A here. This one. This is negative A. Positive A, negative A. When you add, what will come? 0. This here, negative A. This here, positive A. Again 0. This point anyhow is 0. 0 plus 0 is 0. Minus A plus A is 0. 0 plus 0 is 0. Again, minus A plus A is 0. Plus A minus A 0. So how will be the next, if you are going to interfere this, what will be the wave? It will be like this because all is 0. So this is next. Okay. Now let's have the other one. Another form. In the next instant, what will happen? Initially we started from here, it went up, then it will come down again. Okay. When it is going to come down, Let's see that also. Again, it came down. So wave is like this. Then the other one is also the same. Let's see how is the other one now. Okay, so here amplitude 0, here amplitude 0, but here minus A, here also minus A, plus A, here also plus A, here minus A, here also minus A. So how will be the interfering wave or standing wave, which we are calling, will be? It will be like this. Okay, it will be like this. Alright, then finally what will happen again? This point will come over here and this point will go up. In that case, what will happen? It will become again straight. So let me make the standing wave in all four positions so that you can understand what is happening. Okay, in the first case, the standing wave we made, it was something like this. Second one was like this. Third one was in this way. And fourth one again is straight. Okay, these are standing waves. Now let's try and understand where these waves are formed and what these waves are. Okay, so let's see. I'll try to produce these in this string. Okay, you see this is a rubber band in my hand. Okay, and both this end and this end I can say is fixed. Okay, and this the below string I am going to hold in my hand and I am going to produce the disturbance. So what is happening? This entire string is going down. Am I correct? Check again. This entire string is going down. When I am going to leave it, it will come over here like this, and then it will go up like this. So all the particles of this string together, they are moving. Either they are going down together or they are going up together. It's not that half of the string particle is going up and half of the string particles are going down, which was happening in the case of progressive wave. Okay, what was happening in the case of progressive wave? Some particles were going up, some particles were going down at the same time. But in standing waves, all the particles of the loop together they move up or together they move down. What I am trying to say is this. Now in this position, if you see, in this position, this particle here, they are all going up. Okay, like this. And here all the particle down. Entire loop. Again, are you able to understand? And in this case of standing waves, all the particles are not having same amplitude. Okay, now this particle over here, now this particle will never be moving up or down, it will always be at rest. You can check. Here also it is at rest, here also it is at rest, here also it is at rest, and here also it is at rest. So in all four positions, this particle is at rest only. It will never move. Same way this particle, same way this particle, same way this particle. They will never move in standing wave. Okay, their amplitude will always remain zero. Their displacement is always zero. Okay, see this particle then. This particle's amplitude is maximum. Now same particle here also has gone to maximum displacement. Their position is fixed. This particle, this particle, this particle, this particle. Their positions are fixed. This is the particle which will have maximum amplitude. This is the particle which will have zero amplitude. This is the particle whose amplitude will be this much only, whatever that value is. This particle's amplitude is constant. So in a loop, all the particles are having different amplitudes. All are doing SHM? Yes. All are having same amplitude? No. Are all having same frequency? Yes. How can we say that? Because as I told you, in the case of this rubber band, in rubber band, is all the particles going down together? Yes. All the particles are coming to mean position together? Yes. All the particles are reaching to the extreme here together? Yes. Extreme for all are different, but the time taken by all of them to move from mean to extreme is same. So time period of all the particles is same. Omega for all the particles is same. But what is different? Amplitude of all the particles are different. Okay. So these particles which have zero amplitude always, these particles we call as node. These particles are called node. Okay. These are nodes. And this is node. The particles which have maximum amplitude, these are called antinode. This is antinode. And here this is antinode. Same way, these are the same particles. Okay, these positions will never change. Alright, this is node, this is antinode. Now again I will tell you this in another way also. The standing wave formation. With a single loop. Possibly you will understand it in a better way. In a single loop, if I have, this is a string. Okay, now you have given a disturbance. So it went like this. This is what I showed you in rubber band. This particle has maximum displacement, whereas this has zero displacement, this has zero displacement. Okay, have all the particle came down? Yes. Are all the particle at their extreme? Yes. They are all at extreme. Now, when I am going to leave this rubber band from here, what will happen? Next instant it will become straight. Why it became straight? The reason is this, if this I consider as one wave, because you produced a disturbance in the string, then from here a reflected wave came immediately of the same amplitude. When both of these are interfering, what happened? It became straight. It became what? Straight. Next instant what will happen? This string will go up. After coming to mean position, what will happen? It will go up. If you leave, you come over here, then it will go up. So when it will go up, this wave and this reflected wave, both will combine. So what will be the shape? You will see this shape. After that, again straight. So what I am trying to tell you is the shape that you are getting in the case of rubber band. I will show you again. What is happening in the case of rubber band? You see this below string. When I am going to disturb it like this, what will happen next? It will go up, then further up, then again mean, then again down, then again like this, then again like this. So you can see that. It's not visible, it's very fast, but if you see, it's happening like that only. Okay, you can see it clearly from here, closer. They all go together. It's happening like this. Okay, so this is called standing waves. Standing waves of single loop. First down, then straight, then up like this, then straight, then down. This is a loop of a standing wave in which every particle has different amplitude. These are the particles which are fixed. They will never move. And the particle which is having maximum amplitude, that will only have maximum amplitude. All others will have less amplitude than that. And the simple harmonic motion done by all the particles have same time period. So now, let us see mathematically what is the equation of this standing wave. Suppose my incident wave is this, a sine of kx minus omega. Okay, and it's reflected wave, let's say. Same amplitude I am considering, a sine of Reflected wave means it is coming from opposite direction. So k minus x minus omega t plus phi. Suppose I am taking it from denser medium. So a sine pi minus kx plus omega t. So what will happen? This is the second quadrant, so it will remain same. It will remain kx plus omega. Now this and this we are going to combine. This is the equation of standing wave, okay? Which is equal to yi plus yr. So what is yi? A sine of kx minus omega t plus yr, which is a sine of kx plus omega. A we can take common. What we have? Sine of kx minus omega t plus sine of kx plus omega. Okay, sine c plus sine d will be using. So what is going to come? 2 sine of this plus this by 2. So this kx minus omega t plus kx plus omega t gets cancelled. Okay, again sine c plus sine d means 2 sine of this plus this kx minus omega t plus kx plus omega t gets cancelled, 2kx, okay, by 2. Okay, then here cos. Now what? This minus this by 2. So when this minus this you are doing, kx will get cancelled. So what we will be getting? Cos of minus 2 omega t by 2, and cos of minus theta is cos theta only. So cos of 2 omega t by 2. This 2 gets cancelled. Here also you cancel it. What is the equation we are getting of standing wave? 2a sin kx cos omega t. Okay, equation of standing wave is 2a sin kx cos omega t. Now in this equation, this 2a sin kx, equation of standing wave, 2a sin kx cos omega t. Okay, this represents amplitude of standing wave. Amplitude of standing wave is given by 2a sin kx. Okay, then what this is? This is phase of the particle. Phase of the particle is given by omega t, because we know that particles are doing simple harmonic motion. Okay, at any time t, what is the position of the particle is given by this point. Phase of the particle is given by omega t. So right then, phase of particle is given by what? Omega t, or you can say cos omega t. Okay, so this is equation of standing wave, and in this one this is amplitude, and this is phase of the particle. Now the last thing that I have to explain as far as the basics of this standing wave is concerned, I'll explain you right now. So standing wave, this is a standing wave here, with these particles as node. These are nodes. Okay, and these particles are actually not moving at all. These are the particles at rest. So what happens? This energy which is here, okay, this loop's energy, what will happen? Then these all particles will come down and they will go down. It will be like this. Second is like this, and third one, it will be like this. Okay, so this energy will be confined in this loop only. It will come down, this entire energy. Right now, what we can say, this string is stretched. Yes, it's stretched. Its length is huge. Actual length is this only. But if you see that right now, how much is the length? This much. So string is stretched. So what kind of energy they possess? Potential energy. A huge potential energy is there. Okay, now this potential energy comes down, converts into kinetic energy. You can see over here. Here, how much spring? This spring is stretched? 0. So entire potential energy converted into what here? Kinetic energy. Then again it goes down. Again this converts back into potential energy. So can we say what is the energy in this loop is being transferred over here? No. This energy is localized. Okay, it's found in loop only. This loop's energy is not going to this loop. This loop's energy is not going to this loop. Okay, so they are localized within the loop. So because this energy from one loop to another loop is not getting transferred, we call it as standing waves. We call it as standing waves. And second most important thing in this one you can see the particles are all upwards, and here all the particles are downwards. So in consecutive loops, the phase difference between the motion of particle is 180 degrees. This is going down, this is going up. So what is the phase difference between the two? Pi radian. Okay, so remember that these are the basic points about this one. And one more, what is the distance between the two successive nodes? It is lambda by 2. How can we say? Because in a progressive wave, this was lambda. Okay, this is node only and this is also node, because another wave also which we found was like this only. Okay, so this point and this point when combined they became node. This point and this point became node. But what is this distance between two nodes? It's lambda by 2. So remember, distance or separation between two nodes is lambda by 2, and separation between node and antinode is lambda by 4, and between successive antinodes also lambda by 2. Okay, so distance between two successive nodes lambda by 2, distance between node and antinode lambda by 4, and distance between two antinodes is also lambda by 2. Okay, so that's all for today. These are the basics of standing waves. Tomorrow we will solve the problems and further information about standing waves I will give you tomorrow. Thank you.